Be doing a hash map. I already have a hash map, technically. It's just a really bad hash map. I made some custom, like, cache thing. It's technically called table, and it's on templates. It's really bad. Let's use this calloc. I mean, I don't know if I will make this use an arena. Probably not. I'm probably gonna just use realloc. Don't know, but I need it for the compiler, so just do that. Telling anyone to onto this file, but maybe that's fine. So what I want is a struct hash map. And we'll just map strings to void stars. So we'll say keys, right? And now values. I think we'll say capacity and also size, right? Probably does it. Okay. We'll just say, oh, this is an H file. It's stupid. This has so much code, but just since those are classes, it's all in one place. Okay, let's just write hashmap on hashmap map. We'll say string key and we'll say void star value, right? We'll also say, what's up, Beaver? I'm doing hash maps. It's for when you want to look up some text and assign like a value. And it's more efficient because we use hashing to determine what slot the thing will be in. Okay, we'll say find, right? Probably say bool, right? And we'll say void out value. Right. I think we need absolutely is hash map 3. That's just the key. Okay. I think this is all we need for now. Fuck me. It's just like deselecting randomly. Okay. Okay. We'll say this. We'll say this. We'll say this. We'll also have a static void hash map row. Say hash map. And we'll like say, oh, so in a hash map, I think we'll use we'll say U64 for the size and capacity. A hash map grow will just take LM size, right? Okay. And what we'll need is we'll need a load factor, so hash map load factor. We'll make it 0.7 maybe. I think that we want is on a U8 or rather U64. I think. Say hash string. String. Okay. And what I will use for that is actually an algorithm that I found in that book. It's FNV1A. It's an interesting hash. So what it does, I'll move it, or maybe I just do this, right? And we'll hide those two. Okay. So what it does, we start with an offset basis. So that means we say hash equals. And what it equals to is a value. And there's like a table of values we can use. And we'll use 64 thing. So what we'll use this value as the basis. Right? Should be a long, right? And now what we'll do, we'll iterate over all of those characters, right? String, size. Okay. And what we'll do is we'll take this value this time. I'm kind of tempted to use a hex instead. That looks terrible. Also, it's not the right one. Okay, we'll use FNV prime here. And what this does is basically we say hash, and it's hash times this, and also hash XOR by the string data I. I'm pretty sure. So yeah, 1A first does a XOR with the byte of data, and then it does a multiplication by FNV prime. And this is really just it. And this algorithm is like super simple. It's just, it has some very specific prime numbers. So it's like a mathematical analysis that went into it, which I just wouldn't be able to do myself. I'm not a mathematician really, so I think I will use what I actually want, right? Okay. I want to know why it deselects sometimes. It's really annoying. Drives me crazy. Okay. Oh, there's actually gonna be, or I guess Hashmap grow is what resizes it. We'll say, okay, yeah, that's fine. Yeah, okay. Now let's say, let's do the grow thing. I'll say fmap size plus lm size. Actually doesn't make any sense because we are not working on dynamic sizes. Just say +1 is greater than map capacity times the load factor. Then we resize. Or rather, if we are smaller than that, we just return here. And if we aren't, is what we'll do is we'll say hashmap rig equals map, right? Okay, and now what we'll do is for keys, we'll reassign what calloc. Well, let's first do this. Let's calculate the new size. And what we can do is have a resize factor this time, and it will be 2. Resize factor new size equals map capacity times new size. Resize factor. But what we also do is we say the minimum is 8. We don't want smaller maps than 8. That doesn't make any sense. And now what we calculate is the new. Alright, this will be the capacity. Right. Size is not changing here. Right. Case will be the capacity times size of string, right? And the values will be the same thing, but times size of the voice tree, right? Or rather, we just do comma because color is a bit different. And we'll say I will cast it to string. As we'll cast the void star. What I don't really like about this is that it manages its own memory instead of like being arena locked, but that's not really possible to do with this kind of thing. Yeah. It's unfortunate. Because like anytime you want to reallocate, you would have to like it would just waste a lot of space on the what is it? Like on the On the arena, right? Okay. Now we'll say orig, right? And now what we do is we say we iterate over the size of the orig capacity like this. And now if the map values at I is nothing, right? Can we skip it? We skip it, right? And if it isn't, then we copy the key I. We'll actually compute the hash for it. So say string key equals this. Alright, what we will do is we will just add this map. Let's say map, and what we add is, oh, sorry, this should be orig, the original map. And what we do here is we just do the key first and then the value. Okay, so that's really just it. And now hashmap on is will grow the map if necessary. No, one sec. One thing I forgot to do is say, so here if orig capacity, because maybe it wasn't a thing, so then we just don't waste time here. Although the for loop would technically implicitly do that anyways, because 0 is not less than 0, so yeah, this would never run for this case, right? For when it's 0. But what we also do here is orig keys and orig values, right? So free all array. I guess what we can say should really just be this. What we can say is just hashmap free orig like this. Now what this does is map keys, but what I will say is if map capacity, because since this is a generic function, we wouldn't want it to just break. Like we wouldn't want in this case, like we technically wouldn't need this because we already have this, which means actually we don't need it here anymore. But if there was a hash map, so hash maps are initially not init to anything, they're just 0 initialized, and when we push the first value, that's when they allocate. And so basically if capacity equals to 0, then we know it's not allocated, not initialized, so we don't have to free anything, but otherwise we do. Okay, so now what we do is we calculate the hash, and the hash is that just hash string map, or rather key, right? And now what we do is map keys hash modulo map capacity equals the key and equals the volume. Now, this is technically done, but we don't have collision support yet. Have to think of how we solve it. The way I think I'll solve it is I will just say that if there is, so while the thing and the index is occupied, right? So I think the way we do it is actually using the key. Also, this probably should be called maybe grow instead of row, and then if the key size is not set, where you just wouldn't, because like there's no point in mapping an empty string. I think maybe there is. I don't know. It's not very likely. And then mapping a 0 for the value might be something we want to do if instead of void star we want actually to just map it to integer values. So I think this is safer. Yeah, okay. And now while index size, what do we say is index, we say index plus equals 1 modulo map capacity. What's up, Wide? I don't think I have seen you here yet. Okay. Yeah, I think that does it. Right? And we do this, right? We say and obviously if we don't have a size, we just return false because we know there's no a single thing inside of the hash map. But okay, so this actually I can hide now, or even close because we have the hash implemented. I can re-add those. Okay. And now what we do is so here what we do actually is we check, we compare them. So we say string equals, and we compare it with the key. So either says it has, so until the thing at the index either has no size or isn't matching, we'll do this, and then in case it does have this size, we return true, and we outvalue our map values index, right? And I guess I can also protect this if the void star is not set. Might technically be something that's used. Yeah, what's up now, P? Writing a hash map. Okay. Really, I think that's just in, honestly. That was so simple. One thing I probably need to do is removing. And I learned about this tombstone approach where you because usually what I did for hash maps, although I think the hash map, the table I wrote here is actually faulty. Yeah, it is faulty. It is faulty because I don't think I actually remove any. I don't think I actually remove a key any like ever. Yeah, but I'm giving a blank. So let's say there are like 3 collisions, right? You have like 0, 0, 0, and then we have like our value here, and there's another value. You know, let's just imagine those are hashes, right? And I guess it goes here, and then it goes here, and then it goes here, right? And then, so all of them begin here. So now if we remove this one, we actually will check this, and we'll end here, because it will think that it's the end of the search like sequence or whatever. And actually what we would want to leave here instead is a tombstone, which basically means this this slot is not occupied, but it's also not empty. If that makes sense. So it can be overwritten, but it also should be treated as a uh, full element for purpose of search, and also actually growing is one thing that we can also do. So now to test this, I'll in AI test I'll say this. I have a Hashmap for testing, and we'll say Hashmap and map. And we'll say like string literal. We'll say hello, and the value for it will just be 69, and we'll just automatically cast it. And for welcome, it will be for 20. And what we will now do is we'll say, of course, we can free them up. Actually, I kind of like want something like this where I would say, how do I do this? So say 1 here. Okay. So what I do is I do this and I do this and say 1. Oh. Okay, I guess I can't do that. I just have to do it manually. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the reason I'm doing this is because I want to check if growing is actually working. Let's actually test this. Let's see if we have some bad exception or whatever. I think we are stuck. Oh, of course. When we actually add something, we need to say map size plus plus plus. So otherwise we'll never grow and we'll have an infinite loop. Okay, so it worked. And now let's say hashmap find map say string literal welcome 7. Say found. We'll just say something like this, right? Have a void star found equals 0. I will print f our found entry, because we can print it as a pointer so it doesn't complain. What we got is actually 0, which is incorrect. Maybe it's just, no, it's actually incorrect. So we have something wrong here. Let's see what it is. One thing possible is that during resize we lost something. So let's actually inspect this. We have size 12. So let's now see. So map keys 32. What do we have here? And map values 32. So yeah, we only have welcome 0 apparently. Seems very wrong. One thing that is definitely wrong here is that this should be checking orig, not map. This map is still empty at that point. Since the size is 34, which is definitely incorrect. Okay, let's see what happens when we say hello. We'll ignore this. We'll say hello. We'll go into this. It says array grind, case values, capacity, right? So it's grew, right? We increase the size. We get a hash out of the key to get this big hash. And now on the index, we get 3. And since it shouldn't have a size, it says, yeah, we set index 3 to key and value. Okay. Now let's see what happens in welcome. We shouldn't grow here, right? We get a hash, which gets mapped to 3 again. So that's suspicious. Hmm. Okay, but it gets collision gets resolved 4 instead. So that's correct. Right, and now we'll see. It's 2, 3, 4, 5, 6, 7, right? Oh, it already resized. That's interesting. That's completely incorrect when it resizes. Oh, I see why. It's because what we need to do here is actually say map size. Map size is equal to 0. Because we are re-adding them anyway, so we are re-increasing the size. Okay. Well, actually, let's just see what map is. Let's add it here. Map. See, 2, 3, 4, 5, 6 is a resize correctly, right? Let's see, map. K16. And this is actually a dot because here we are not using a pointer. Yeah, so you have welcome 3, welcome, welcome 2, welcome 4, welcome 1, hello. And they seem to be spread apart. There's a bit of clustering here for some reason. And the reason is probably because they are very similar strings. They all have the same beginning, and then they just have a very like 1, 2, 4 is just like a very small difference in actual ASCII value, so that's only what it is. And now if we say find, right, we go to find, and what do we get is a hash. We get an index of 12. Oh. Maybe I do a while true loop. Right. We say this, we say while true. Or rather, maybe what I do instead is I say while the size is set. Just like we used to here. Right, I should do it, I think. Ah, does work. So we have a working hash map. I'll actually add removing because it should be trivial. Void hash map. Remove hash map string key. Okay. Actually, I kind of like it in the reverse already. This can probably just be a one-liner. Same goes for here. Set the size here, okay. And now hashmap remove will just say the same thing as this, right? And now if this is equal, we say we send the key. We say data 1. I think is what we will do. So now for finding if map keys index data equals 1, I think I'll make this like thing. Summary, we'll say like static const char star. It's like tombstone value. Say const. Well, I don't want any writing to the pointer line. Yeah, I can't do that. It's silly. So I think what I will say instead is tombstone value const, and we'll just say char 1, and we'll do it here, and we'll also do it here. And in this case, we just say continue, right? Maybe if it isn't a tombstone, that's when we check. Right? So I'll just explain that this is like an actual trick because we just know instead of like allocating additional data, I just know that I guess another thing I can probably do to be safe is set the size to 0. Let's return true, I think. Return false. Oh. Hashmap remove, right? String key. Right. Actually, what I should do here is say a static S64 hashmap, or rather, this can just be static U64 hashmap find slot, and we'll say hashmap map string key say bool allow return stones, right? And now what we'll do here is we'll just say this, right? And now iterate, right? And now if the map keys if the data equals to tombstone value const, and we say if return tombstones return index, right? should be unreachable, right? I guess I will keep that. It's the way I'll structure this. I'll have it as an else if, right? And now what we'll say will string equals key this, and then if so, we'll say return index. So actually, what this could be is just this. Or this, which says, actually we'll say if no. Yeah, actually it's kind of more tricky because what I have to say is this. And yeah, actually I will go back to using just this. Right, and here we return the index. Actually, here I should just return the index, right? Let's think about it. How to structure this the most sensible way. Yeah. So it could say here is if no return timestamps, right? Oh, those two shouldn't be needed. All I need here is this. And now for find, what I just need is index, and it will be hashmap find slan map key, and we'll say we don't want to return tombstones. And now if the if this has size, what we'll do is just this, right? Yeah, if it has a size, it means it was found. And then in add, what I can do is I can allow finding tombstones. And now I will just say like this. And what I should probably say here is that if we find it, this is some potentially unnecessary work, but what I would say here is we should make sure we don't care about this. And if we find this, we should just return, right? Let's say this. So this makes sure that we don't add the same key twice, but it's actually slower now. So I'm not sure if that's a good decision or not. And now this one, actually, what I can say is what we can say here is if this has a size, we would say would return it. It would set it to a tombstone. Right? Is this it? I don't know. Let's see if this even works. It seems to. Let's say I remove Hashmap, remove. So actually, let's take all of them outside of 7 and let's just remove them. Don't need those. Let's see what we see. So this is a 32 big set. So really doesn't interest us. And you know, any error reading character is actually, it means it's a tombstone, right? Because it's 1. And now we still find welcome 7, but you can actually see that welcome 7 was not affected. What is affected is just welcome. So let's see if for welcome we actually find it correctly. But we seem to be able to delete them correctly, so I assume this just works as intended. So now when we see welcome, right, it's here. And it does find it, and the value for it is 420, right? Found as a yeah. Okay, yeah. So we have hash maps. That's gonna be very useful. Okay, that should be it for the hash map. And now what I think we should do is for our things, is it resolver? Yeah, so here we would say hash map parse, hash map funcs. Right? It just works, correct? Now what we need to do is we also need a thing for free type scope. Type scope is all we need, I'm pretty sure. And what we do is free hash map, rather hash map free. Type scope parse and funcs. Okay. Now what we do here is we say the map being a type scope vars, right? The key being in the var slot name, right? And the out var is just var, and then if we find it, we say yeah, we can't do that because what you're looking for is slot name, not var slot name. Okay. As actually is correctly a variable type. Sorry. Okay. I'll actually do that here. Or rather, this is void star like this. Rather, void star star. Sorry. And now what we do here is hashmap. Hashmap 1 on find 3 no on. We say type scope. This is for vars, right? Say the key is the slot name and the value is the var. Okay. And now we'll need the same thing just for funcs. So we'll say funcs. We'll just say the name, which is function name, like here. Okay. And now what is needed here is a hash map. Alright, this is a function type. It's func. And what we are looking for is the name. Okay, let's see if that works. And it doesn't seem to work. Let's see why. Oh, the reason is because we're looking in the wrong file. We're searching in the wrong scope. Here, in the wrong hash map. I'm sorry. And I think we work. Seems to. Okay, and now what we need to do, by the way, is wherever we finish here, we say free, rather hashmap free, and it's the rather even better type scope free, free type scope, and it's this type scope. And now anytime we unwind a type scope, we also want to free its just free it, right? Because we don't want to leak the hash maps. And I think the way I will do make sure we don't leak them is in array. I will say so free. So I kind of wanted here, right? Printf free hash map, right? Say like a bool dby equals true. And now bool dby. This is something I will remove just in a second, right? We don't want it recursively call here, and another thing that we do is if no capacity, that means we actually need to say alloc hash map exclamation mark, and we'll say we'll use the same formatting here. Let's see if that works. So let's grab this. And let's see how many that is. And that's actually a pretty scary amount of allocations, but so it seems like we have a magic count. So that's good. Okay, so now let's revert those changes, right? So they were just for some quick testing. Okay. Now we also revert here. Okay. Now remove size, tombstone, return, okay. That just works. Yeah, that's pretty cool. I wish they had like some simple clocking utility. I need to run like a benchmarking utility. Probably using like the structure tweak where they automatically finish. And maybe what I use is actually hash maps because then I would map the name of the benchmark and would group its value to one thing. Right? Could be pretty cool. Kind of tempted to do it, but it would actually be recursive if we use it in the hash map because if it would use hash map for the lookup, and it's the it's this, and it's a 64-bit version of. Oh, actually, wait. Since to be S64. Okay. And what it is an x64 version of Fowler null Vu hashing algorithm. So this is it. This is this variant. It's just the better variant. This is what I just found in the book, and it looked better than what I used to use. And I also wanted to rewrite it in like more C style thing. I don't know. Are you familiar with this algorithm? And like the idea is very simple. You just XOR it and you multiply it. My hash was here. I like shifted by a multiple of the index and added like an offset depending on the index. So this is like probably pretty bad, especially like this thing. And I also never XORed, which is probably a mistake. I didn't even like realize is the tables I wrote, the template tables I wrote pretty like ages ago. It was even before I did proper netcode, and I didn't really realize what XOR is actually doing. But yeah, this is a very simple algorithm. The only thing is, it has some really nicely chosen prime numbers that I wouldn't be able to find myself because I don't have a major in mathematics. Kinda would kind of want to know how to actually find those, but I assume this like just was lots of testing too. So, uh, anyways, Mathema magician. Yeah. Oh, I've fucked something in my OBS setup. So give me a sec. Okay. Yeah. Okay. So we do have hash maps. I needed them for functions because we'll add native functions, and I wanted to make them more sensibly. Although I honestly didn't need to write this. I could have just reused my like weird list approach, but okay, let's do native functions. Let's actually do them. And I think what we need for that is what we should do here is like um what is the name for that? Well, I guess vargs, and this is native only, allows any amount of additional params. Variable, I'll just say vargs, that's fine. I mean, what we kind of need is, I think I'll create a new file, and it's gonna be called AI native, I think. Move it here. We also move it to src. Oh, I have so many files. And what AI native will do is it will take, say, define native functions, maybe add native, define native functions, maybe, and we'll take a type scope types. Right. We'll include AI. Rather, I will just define this as struct type scope. We don't really need to do anything outside of that. And in AI native, what we include is we include the AI resolver. Oh. And I guess what we also need to pass here is an arena. Arena, okay. And I don't remember, yeah, they're called arena now. Kinda hate doing that, but whatever. Actually, that's fine, we can put the resolver. And what we will do is we actually will only include the AI native inside of the AI resolver CPP file. Okay. And now what we need is like it's like static for make native. So this is probably a function literal, right? Make native function. I'll say the name, right? Name. And what we'll probably have to pass here is all of that garbage. Right. Right. Okay. And now what we'll do is we'll get actually no. What we'll do instead is static void add native function. And we'll pass it the literal. This will just be hashmap and type scope function, right? Key. Key will be whatever the function name is, right? Function name, right? As will be new func, actually. Now what new func is also function literal. Just this time it's allocated on the arena. New func, and what's actually neat is I can remove the links from those. Not from this one though. But from function literal and also from, or is the function literal that I can remove it from? Oh, kind of goofy. No, so what I'm actually thinking of is type function, and it's an AI resolver. This kind of can just be removed completely. But maybe we'll have something more here, so maybe that's not necessary. And what I will say is func type, actually, and this will be function type, right? Func type, and the struct is function type. What we definitely don't need here is the link, though. It's no longer necessary. And now the question is, do we store the literal here or no? Probably none. This is not even a stable address if it's in a hash map, which means we can't make a pointer to it. So it's kind of wasteful to store it as a value. It's not useful. It just means that we also have to make this be duplicated, right? Well, maybe what I do here is I say this and I say func, say arena, for func, and func name, what's name? Func function. I think what I also need here is native, right? Right, maybe native idea is what we use, and we'll say we'll create it here. Say in native function ID, you'll say none. Let's do assert. Also passed as a function, or rather native function ID. Give it an ID. Okay, that should do it. And now basically what we would say now is we would make literal assert equals this. I'll say native assert, we'll say arena string clad, we'll say assert, right? We'll say native function ID assert, like this. And we'll add it to the type scope arena native assert, like this. And I guess helper function is probably make and on native function. Because those might be, or I guess doesn't really make that much sense. Because what we need to do is we need to add params to it. Say function. Pass the arena first, function literal, and we'll say, so what defines a parameter? I forgot. It's a token, it's a slot, and it's a runtime type. Probably don't need to resolve them per se. Param equals push-struct parameter, and we'll say list on function params param. And now what we need in the param is the slot name equals name. We'll need a type equals type. That's probably it. Doesn't have a Alexa slot. I will say string name and we'll say runtime type, right? And now what we'll add to native assert is arena runner. Actually, I kind of would prefer it the other way. Say native assert arena. Maybe arena is last in this. We'll say the name is string lid. I don't even know why would I need a name, honestly. Maybe for debugging is where we would use it, but say condition runtime type integer, and then we'll say string. And I actually want this to be optional message. Oh yeah, set result type is probably what we need. Set result type. This is so simple that maybe we shouldn't even put a. Maybe we shouldn't even use a function for this, but whatever. Let's say it returns an integer. And what I really want is product native function, and what we'll say, or maybe what we do. I think making it an ID based thing is better. And honestly, this is kind of not necessary. Because what I will say instead is I will say I think I'll use a U. I guess U8 is probably fine for now. Using a U8 here as well. Native ID. And what it is, it's actually. I will just always just say ID++ is what I do. Hmm. But now how do I dispatch them? I think the functionality system was better for that. So I think I'm gonna get back to it for now. Okay, and we'll re-add it. Yeah, this can be a U8 for now. Or honestly, it can just be. I mean, it is. I want it to be U8 because I would have opcode native call, right, as a thing, and then you would just take a bind. So there's a high chance we won't use more than 256 functions, and if we do, actually 0 is reserved for non-native functions, but non-native functions live here, basically. Now they will say a Spark native function, and what they'll say here. This actually requires a runtime. Because we need an exec unit. Exec. Right. So you'll need to pop things. There's also the runtime. Specifically Kairos runtime. We'll use the native ID. Right. Right. Well, honestly, we probably don't need as much. We probably don't even need the exec, although maybe we want it for exec errors. But what we really need is just a runtime value, and arc count. Right. And now switching on ID, I would say case native functionality assert is where we would say runtime value condition equals values right? Values or arcs maybe. I'll say if arc count equals 1, then we do something. If it's equal to, we'll do something else. Otherwise, we'll actually do this. Honestly, I don't really feel like doing anything else than just this, and say if condition integer. If it isn't, so well, we kind of need to allow any function here. Fine. Like this is kind of dumb. But what this should do, I will assert here that condition type equals runtime type integer, right? And that this equals string message. And in this case, we just say search and failed. Kairos search and failed. Say this weird fucking syntax. What is it? Percent s will say message. And this is actually wrapped in string format. Right. Okay. And what this should actually return is runtime value result equals something. Or result. And I guess what I can do is I will just result to condition integer as my thing. Just condition will be my result. Okay. Okay. So that I'll also say here is add support, so port print to native functions, make it so add support for var args. This is what we will eventually want to do. Fine. As you should also assert that the arg count equals to, because those things should just be true if all of this definition here is true, right? Maybe doing like this. Okay, and now what we need is an AI runtime. Have opcode call. What I will say is native call. And add support for it, and I will say native ID. We definitely need here is AI native. Oh yeah, so one thing that we need to do in AI native. So first thing first is we need to expose this, right? And the second thing is when we add a param, what we also want to do is function maybe what we should have is like a param counter, right? Huh. So what is opposite of native? I guess I'll see Kairos, but what is the prompt? Should put maybe after the name. It's literally how it's defined normally, so. Okay, so in here what we do is we say native. We proc the native ID. Cast it. Now I think we should have a param count here. Param count. And now anytime we write to params, like here. So anytime there's a list on, I would just say params function param count plus plus, right? That's weird because we only see 3 things. Oh, maybe. Oh, yeah, this is the first one. Okay, whatever. Okay. Uh, so there's now something called arcs function arc. What is it? We have like some arc thing. So when we resolve a function, right? Maybe it's function call specifically. No. Oh, I think it's in compiler. Yeah. So this count thing. This is pretty garbage. And what we want here instead is we just want this instead. Because params param count like this. Sly, yeah, we don't use that. It's garbage. But what we need though is we need this to be accessible somehow. I'm not sure how. I think what I need is actually native function. Native functions, right? Huh. So how do we do this now? Well, definitely when we compile this, when we compile a function call, right? If actually this thing, so if the expression function call so weird. Oh, this setup is so annoying. I wish resolver and compiler were one step maybe, but I don't know if that's I don't know if that's possible, especially if we want to do optimizations later. Is this still used? Yes. Okay. What we say here is U32 native ID and also probably arc count, Question mark. Don't really know. Huh. See what I think I will do here is I'll say native ID, right? So what I will say here is if we are in a native call situation, we'll say native call. Say the native ID, but we'll also say arg count as the next statement. And in runtime, we'll also say then arg count. Right? We don't really care about call frame. What we care about is supplying this first runtime value. And it's basically the top of the stack. So I'll say exec sp minus arg count, right? Yes, okay. And now this is the exec stack. This is what we give it. And what we say here is we say values and arg count. And now what we do after that, we pop those values. And tell me if I'm wrong, but I think popping is just, yeah, decrementing the SP. So yeah, I'll just do it manually or count. But what I will want to do is I want to make sure that the exec SP is at least as big as the arg count. And if it's actually smaller, then we say exec error, exec not enough arguments on stack for native call. And what do we do is break after it. Okay. Okay, so all is good. Now one thing that we need to do is when we do function calls in the parser, yeah, when we do them, we need to also now set the native ID. And we'll have to set it to the, I think that has to be done in resolver actually. Function call. Yeah, okay. And now I'll say function expression func type function native ID, right? Yeah, that should do it. Maybe that should be part of this. I know this line is something else. And now what I kind of want to protect myself from is incrementing the function slot if the function native ID is set. So if it isn't, that's when we would take a slot. Actually, that is not even necessary because what we'll do here is we'll say declare native to include AI native, right? Say declare native. What is it? Define. Okay, that's fine. I will say the global typescape. Alright. I will use the resolver temp arena. Or this is actually scope arena is what we use. Good. Okay. And now let's see what happens when I try to add an assert function that says assert, maybe not 12 by the way, maybe it's 3 is not 9, and I'll say 3 is not 9. But if 3 is not 9. So since this is false, or rather, let's see this. 3 is not 9. Since this is false, it should work, but now we have a runtime error for attempting to pop a non-existent value. Okay. And also one thing that I broke is then when I say oh, it almost works. Attempt to pop a non-existent value. That's interesting. So Kyra's essential assertion failed. So this is this should probably be its own thing. Should be a log info, probably. It almost works. We just have an attempt to break the program. Function call. Oh, right. So what we need is actually the return value result, and what we do here is exec push value result, right? So what expressions do, they return something. And it works. We have native functions, so what I'll say here is I'll say add native function support, and this was done. And another thing what was done today is add hash maps, which is actually not as necessary as I thought it would be, but it's fine. This is something I can do in a sec, I guess. And now we'll say start testing. Maybe what I say is like this. I don't know if that makes any sense, but whatever. And we'll say probably do this just now. Okay. I think there's actually no max here, maybe none. Yeah, this is where I moved in. Now all of those I have to add here, right? Say case. Okay, we'll say push async. Yes, was thankfully very easy. And then after is actually both an expression and a statement. I kind of feel like after, every, and when are kind of like noob traps because they actually, it's probably better to just write the while loop yourself. Because then you get more control over it. Even wait until is probably a noob trap. Since you don't have any option to actually interrupt it. So I have to think about that. But even if it is like something that doesn't isn't like the most powerful option, it's probably still worth to have it because it's pretty readable and intuitive, I think. So it's probably very useful. Okay, and now print expression, we have function calls. This is the wrong order. And then somehow unary is okay. And now what we need to add is push through. Push through. Now what that is just push through. And really that's just it. See if we still have any unknown types. Don't seem to see any. Yeah, there's type 9. What is this? This is 7. Identifier op is not supported, interestingly enough. I think we are probably the wrong ordering. So if while declare, so 4 is missing here. 4. 4. We also have init, and we have post init. Oh, by the way, this push through actually shouldn't have printf. Push through. Oh my god, I can't type. Okay, I should just do this. Really, what I think should. Holy fuck. You see this? This is one. Okay. Oh, better refactoring it, but essentially it would be better if we just didn't have this implicit printf here, but we do. Okay. Really, all this I'm writing should just be handled by metaprogramming, but there's no metaprogramming in C, so or C++, really. Okay. So declare function, declare. Oh, actually, there's something I remember. Just remember, there's a problem in the parser, and it's can. Maybe it's no, it's definitely here. Sign. So yeah, here. What I want this to be is actually allow declare, because we always want to allow the sign. Actually. Because when we should be, we wouldn't be otherwise allowed to say I equals I plus 1. And well, maybe this is goofy because there's a better alternative, which is plus equals 1, or eventually plus plus on either side. That doesn't really matter. What does matter though is that you might want to make this a function call like next I or something, right? And also like more things here, right? So sign should definitely be allowed. Okay. And now going back to the print statement stuff, for the for loop, we have the pop n, which is IU32. Okay. Declare, assign, return signal. What we should do here actually is print okay, what we should do here is print a scalp. Pop it, and we should also say, here we say print depth, right. And it actually is just print expression, the statement, return signal dot value, and the name is just value, and the depth is just the depth. Okay. Expression statements. I don't think I have anything special about them, and then everything here is supported outside of identifier up. Which is the only one that we didn't have. Okay, and let's see. Identifier up. So when we have binops, right, what does it say? Oh, I didn't bother. I should print here is print f. It's probably just probably move it here, and it would be the expression binary up, and I think this is how to select token type. That sucks. Just say U then, just as a number, right? Just same for unary, and the same for identifier up. Except for unary, I have to rename this to unary up. And then navigating Visual Studio is painful. I wish I had something better. Or at least that I knew something, some like better shortcut or something. Okay, so this is the op, right? But if this is the mouse, I will be pissed. If my third, like, mouse in a row has to be returned, or maybe it's fourth mouse in a row has to be returned, because like sometimes it's like it seems like a click after the button release or something. Maybe it's Visual Studio specific. I don't believe that, but who knows. I probably will add like a static void. So all of those I can probably move up. And here I say static void print variable slot. And all this is a print tab. Tab. Maybe it's just printf percent. Oh my god. It's this, right? And string format. Slot. Name. And now another thing would be slot. This global namespace, we would say space global, right? Otherwise we do an empty string. And then another thing is slot sp, which just will always be here, like this. I think I can swap them. Yeah, okay. And now when we have identifier up, we'll say printf to this. We'll use the slot and we'll use, yeah, okay. Okay. I guess what I should say here is college char name, like here, and we'll say name. Rather, maybe it's label. Label. Right. And then if label, we say label, and otherwise we say slot, question mark. Slot. Maybe what I do instead is I say if label and printf percent. I say percent s label like this, right? Okay, and here we would say print variable slot identifier. Oh my god, it tilts me so hard. So much. Here maybe I just say slot works. That was the original I used. Here I'd say we also slot. Or just say like that. Now here I actually just don't do anything else is 0. I think. Okay. So we have declare in slot test global 0 const. Oh, printing slots is useless. Okay, good to know. Slot SP is always 0. Or maybe what I'm doing wrong is I'm probably printing before resolution, right? I'm probably doing that in the parser here, right? Yeah, okay. I moved that here. Or maybe what I do instead is maybe I either print it here or here. Just kind of funny. So yeah, if we are able to resolve it, we print it after resolution. If we are not able to, so print is really fucked. Statement type print. This is an expression type print. Okay, the reason it's fucked is because I don't actually know why. It's probably because identifier now does this, but also needs to do a new line. And here we have something stupid. Dude, I just need to add a new line here, and that's it. Printf. Maybe I shouldn't because we might have a problem with that. Forums, that's fine. Here we already have that. And assign we need done, right? Here we need done. That's probably it. have to fill those in. Say delay condition. And here maybe I actually call this async scope. Right, and here I say delay. Okay. Hmm. So what happens if in this assert I say like 2 and here does it just glitch the program? Param was no. But it does just compile it correctly. What? It's parsed nicely. Okay, that's good. I should make those errors more informative. It should say what was expected and what was given. Currently, it just says that it's incorrect. You kind of need to know why. Okay. Yeah, that's cool. I think that's it. I'll push my progress. Progress from stream. This is actually 10 May 2023. Even though it's technically 11 May for me. Count it as 10th because I will also do a stream on the 11th. But yeah, we have, let's see what we have here. Have a third, we have this actually. And this is gonna take, this is gonna be added later. Okay, let's actually just say, update to do. Okay, yeah, that's it. So thanks for coming who was here, and I'll see you tomorrow.